Hey, hello. Welcome to Science Chorus. In this video, we're going to see about carbohydrates. So before moving on to the concept of carbohydrates, let us understand few important terms related to this. So the first term is stoichiometry. So stoichiometry is the calculation of reactants and products in chemical reaction in chemistry. So for example, if you are taking a particular chemical reaction, say A plus B gives C. Okay, so you just imagine that these A, B, C are some chemical compounds. Okay, so the left hand side compounds we call it as reactants, and the right hand side compound we call it as product. Okay, the calculation of these reactants and products, okay, that we will be calling it as stoichiometry. Okay, and the second term is organic compounds. So according to earlier scientists, these compounds are derived from living sources like plants and animals, or these remain buried under the earth. Okay, so according to the earlier scientists, the organic compounds has been considered like the compounds whatever we are deriving from the living sources. Okay, it can be plants, it can be animals, or these remains, okay, which has been buried under the earth, that has been considered as organic compounds earlier. But according to the modern concept, these are the compounds that consist of carbon and their derivatives. So the important thing which you need to remember is the presence of carbon in the chemical compound, okay, and their derivatives. And it is not only carbon, it can be hydrogen, oxygen, all mixed up together. Okay, so carbon is the major element present in the organic compound. Along with it, it can be hydrogen, nitrogen, oxygen, and all those things. Fine. So these are few important terms to be kept in the mind. So now let us move on to the exact definition of carbohydrates, and let us try to understand that. Yes, so the term carbohydrate is derived from a French term, hydrate de carbone, meaning hydrate of carbon. So we need to know what is meant by hydrate. Hydrate is nothing but which consists of water in it. So the term hydrate is nothing but water. Okay, so hydrate of carbon. Okay, so the general formula of this class of organic compounds for carbohydrates, okay, so this carbohydrates is a class of organic compounds. Okay, under carbohydrates there are different chemical compounds. The general formula for this class is C n times and H2O molecule n times. Okay, n can be 1, 2, 3, it goes on. Okay, now a carbohydrate is a biomolecule, which we already know. Bio is nothing but life, right? Molecule is nothing but when two or more atoms combine together we get a molecule. Okay, so a carbohydrate is a biomolecule consisting of a carbon, hydrogen and oxygen atoms, usually with the hydrogen oxygen atoms in the ratio of 2:1. Okay, so as I mentioned, it is a hydrate of carbon. So water molecule is present in carbohydrates. So that's why I mentioned it here, right? So the general formula, if you see, it is H2O n times. Okay, and this H2O, hydrogen and oxygen, is in the ratio of 2:1. Okay, now considering the definition of carbohydrates, whatever we have seen now, it is not the same for all the chemical compounds. Like the general formula does not apply with all the compounds. There are few exceptional cases. Like, however, not all the carbohydrates conform to this precise stoichiometric definition. What is meant by stoichiometric definition? It's nothing but the number of reactants and the products. Okay, so in this case, the number of carbon and the number of hydrogen and oxygen atoms. Fine. So however, not all the carbohydrates conform to this precise stoichiometric definition, nor are all the chemicals that do conform to this particular definition automatically classified as carbohydrates. So it's not that all the carbohydrates will be having the same general formula. There are some exceptional cases, and few chemical compounds will be having this particular general formula, but they will not come under carbohydrates. Fine. So now let us take some examples so that it will be easy for us to understand. Yes, so example, acetic acid. Okay, so acetic acid is an exceptional case. Okay, the formula for acetic acid is CH3COOH, but acetic acid is not a carbohydrate, right? It is not a carbohydrate. Now what is the general formula? It has it's been CnH2O n times, right? When you're comparing with the formula of acetic acid, what has happened? Now if you're considering n is equal to 2, okay, n is equal to 2, so C 2 H2O 2 times. So CH3 COOH, right? So what has happened? Totally 4 hydrogen atoms are there, right? H2 into 2. 4 hydrogen atoms are there, 2 carbon atoms, 1, 2, 2 oxygen, 1, 2, because this 2 comes inside, right? So totally 4 hydrogen atoms, 2 oxygen atoms and 2 carbon atoms. So this acetic acid is like it is having the same general formula which we have seen for carbohydrates, but acetic acid is not a carbohydrate, right? So this is the exceptional case which we can see here. Okay, let us take few more examples. So formaldehyde. Okay, so in this case the formula is HCHO, but formaldehyde is not a carbohydrate. What is the general formula will be for this? C1 H2O 1. That means N is equal to 1 in this case. Okay, N, if you take N is equal to 1, and if you are applying it here, C1 H2O into 1, right? So what has happened? 1 carbon, 2 hydrogen, and 1 oxygen. So formaldehyde is having the general formula of carbohydrates, but formaldehyde is not a carbohydrate. Okay, this is an exceptional case here. Fine. So now moving on to the next one. Yeah, rhamnose. Okay, so when we are considering rhamnose, it is a carbohydrate. Now let us see what is the general formula for this. Okay, so it has got 6 carbons, right? So N is equal to 6. So when you're applying this to the general formula CN H2O, this is the general formula. Once again, I'm just writing this CnH2O n times. So when you're applying to this C, 6 H2O 6 times, right? So what has happened now? C6, you will be getting H12 O6, right? So what is the difference now? You can see the difference easily here, right? Here it is O5, but what we have got actually it is O6. So this rhamnose is not binding to the general formula of carbohydrate, but still rhamnose will be coming under the class of carbohydrates. Yes, these are few exceptional cases where some of the chemical compounds will be having the general formula of carbohydrates, but actually it is not a carbohydrate, and there are few carbohydrates which does not bind up with the general formula of carbohydrates. Okay, yeah. Moving on to the next one. uh, these carbohydrates are also known as saccharides, which is derived from the Greek term saccharon, meaning sugars. So generally these carbohydrates are also called as sugars. The importance of carbohydrates, we have got lots and lots of importance of carbohydrates. I have just listed down few of them. So the first one is source of energy. Carbohydrates are considered as source of energy, and in animals they receive starch, which is, see, this starch is a carbohydrate, okay, which is present in rice, potato, etc., okay, from the food. And plants, by undergoing the process of photosynthesis, they produce carbohydrate, which is nothing but the glucose, okay, which is being produced by the plants. And the second important thing is it is giving a particular structure to the plants, structural function. So in case of plants, cellulose, which is a carbohydrate, is present in the plant cell. We know that plant cell consists of cell wall, okay. So this cell wall is nothing but the outer layer of the plant cell, which is made up of cellulose, okay. So again, cellulose is a carbohydrate, okay, which is undergoing a structural function, okay. And the third one is heparin, okay. This heparin is actually a complex carbohydrate, and it is acting as an anticoagulant, okay. It is acting as an anticoagulant, which is nothing but it prevents blood clotting, okay. In many cases, due to blood clot, there is a chance of there is a high risk of stroke and other things. So this heparin, which is a complex carbohydrate, will be acting as an anticoagulant, that means which will be preventing the blood clotting, okay. Now I think you're clear with this, right? Moving on to the assessment part. So we have discussed about carbohydrates and few important terms related to it, and the general formula of carbohydrates, and some exceptional cases where it was not, some few chemical compounds were not following the general formula of carbohydrates, and there are some chemical compounds with different general formula. Okay, now coming back to the assessment part, the first question is dash is the calculation of reactants and products in chemical reactions in chemistry. So stoichiometric, stereometric, molarity, none of this. So the answer will be stoichiometric. Okay. Moving on to the next question. The general formula of carbohydrates is dash CH2O, C n number of times into H2O n number of times, or CnH4O n number of times, or C2H3O n number of times. So the answer will be B. That is C n number of times. So n can be number like 1, 2, 3, it goes on. Fine. Yeah. So moving on to the next one. Acetic acid is not a carbohydrate. Acetic acid is not a carbohydrate. True or false? It is true. It is not a carbohydrate, but it will be having the general formula of carbohydrates, but it is not a carbohydrate. Moving on to the next question. C6H12O5. Okay, you need to name the compound. A. Stachyose, B. Glucose, C. Verbascose, D. Rhamnose. C6H12O5. It is rhamnose, which is a carbohydrate. Moving on to the next question. Saccharon. The meaning of the term saccharon is carbon, salt, sugar, hydrogen. It is sugar. The meaning of the term saccharon is sugar, and generally we will be calling carbohydrates as saccharides, or you can call it as sugars. Okay, so this is all about an introduction to carbohydrates, and in the upcoming videos let us discuss about the classification of carbohydrates and all those things in detail. Thank you.